previous video, we learned to represent a classification problem with more than two possible classifications as a perceptron. What about the activation functions for these problems, Dr. Murthy?
Now this is not done yet, okay? Because when I randomly or learn these values, there's no way these will be. How do I want my output? Let's say COVID guy, I want it to be 100. Flu guy, I want it to be 010, which means this node output should be 0, this node should be 1. And healthy guy, I want it to be 001. But if I leave it without activation, these values will be 28 minus 32 plus 64, whatever those values may be. So I need one activation to actually bring these to that 100 format. So that activation is called softmax. So let's go to softmax function. So here is a good way to, this is a good description. So softmax is, what do I do? Let's actually, probably it's better to do it in Excel. So let's say I did my W1 X1 plus W2, similarly H1 X1 plus H2 X2, K1 X1. My values are 24, minus 18 and 32. Let's say these are the values. Now, when I softmax it, what do I do? First, I raise it by e power. So exponential I get these values. Now I add them all up. Sum of these values. So in the softmax, I first exponentiate it. As you can see, I first exponentiated, and then I added all of them. That goes into my numerator. And sorry, denominator. What will be my numerator? The first guy divided by this sum, and the second guy divided by this sum, and the third guy divided by this sum. So obviously, when I add this, it will be equal to 1 because I normalized anyway. And you see nicely it got converted into a probability. It's almost like 001. So these values now transform themselves into 001. Again, you may ask, how did you know to use sigmoid? How did you know to use tan H? Why only softmax? Is there no other way to do it? Of course, I could have taken, instead of e power x, I could have taken x squared plus y squared plus z squared, x squared divided by x squared plus y squared plus z squared. That's also, it'll lead to 100 and all that. But it turns out that the functions that we have chosen have very nice and simple gradients, slopes, derivatives. And that's why we are preferentially choosing them. So I'm sort of cheating. I'm introducing you to such activation functions which have very nice derivatives, properties and derivatives. And that helps in doing the rest of the mathematics. So there are two reasons why we choose it. Number one, it fundamentally satisfies the requirement that, hey, you know what? This has to be, this has to be a 100010001 kind of a thing. In addition, you know what? It should have a very good derivative. So a multi-class classification problem in Perceptron, the activation function is softmax, where I build multiple regressions, one for each class. And once I get those outputs, I now put them through the softmax function to get a probability distribution.
Ah, the softmax is very elegant indeed. Does it then solve all classification problems?
By the way, there are two types of multi-class. One type is what I said. Hey, you know what? Is the patient suffering from COVID or flu or some healthy? There it is a either or. It can be either COVID or flu or this thing. Or is it a cat or a dog or a horse? Again, it's either this or if I have one photo. But if I have a photo where there is a cat, there is a dog. Now the question, it is also a multi-class identification this time. Identification. For cat, it should be one. For dog, it should be one. Let's say the third class is human. There's no human in the photo. It should be zero. There it should be 110. When I have, when there is a possibility of multiple classes, okay, my answer should, I should be allowing an answer like 110, 111, 011, because all classes are possible simultaneously. So if I give a photo and ask you to figure out, hey, tell me what are all the animals there, then it's a multi-class problem still, but multiple classes simultaneously can occur. On the other hand, if I give one photo and say, hey, figure out whether it's a cat or a dog or a horse, it has to be either cat or dog or horse. Softmax works when only one class is feasible because it converts it into a probability. If it is multiple classes that are feasible, if it's multiple classes that are feasible, very simple. I just do a sigmoid here. I just do another sigmoid here, another sigmoid here. I get a value here. I put it a sigmoid. It will be 1 or 0. Another sigmoid 1 or 0. Another sigmoid 1 or 0. So it is a very important thing to understand. Depending on the problem, after the perceptron multiplications, you actually do a softmax or a sigmoid.
Oh, so depending on the type of classification problem, the sigmoid or softmax is the beta activation function. Thank you for that insight, Dr. Murthy.